Thank you, Luca. And yes, it is true. I host multiple websites, my side project on this little device that you see on my desk here. And yes, I do need duct tape sometimes because this is on my desk and I just sometimes kick it and it falls off. But nevertheless, I still manage to handle quite a bit of load on this little device, even though it's connected through my Wi-Fi network, which also isn't ideal nor optimal. But as you can see here, in the last month, I had 500,000 requests served through this Raspberry Pi. Which I know isn't a lot, but it's also a lot more than zero. And I know most of these requests are not done by humans, they're mostly bots, but you know, robots are people too. So I do sometimes get a little bit of downtime. That's usually when I accidentally hit the Raspberry Pi and it disconnects. But even though I had 7 minutes of downtime back in March, my uptime is still pretty decent. And these are, of course, side projects, so it doesn't really matter that much if the site goes down for a little bit. So what I'm here to tell you today, that this might not be a good idea for your company use cases. Your customers might get upset at you if your site isn't reliable enough. But I'm also here to tell you that it is possible to have a website running in your home and that it actually can be a lot of fun if you find configuring Linux servers something that's fun. That might be just me though. So you're probably wondering how to get started with this. What we need at first is, of course, some hardware. Now, I will be talking about Raspberry Pis, but I do want to note that it doesn't actually have to be a Raspberry Pi device. If you have an old laptop or an old PC somewhere just gathering dust, you can always repurpose it and use it as a little Linux server. Now, I like to use a Raspberry Pi instead of an old laptop just because it is very small, it is silent, and it doesn't use a lot of energy. The Raspberry Pi itself is quite cheap. You can get it for like 60 to 70 euros, depending on where you live. And it is quite powerful. It comes with the latest version, the Raspberry Pi 5, comes with a 2.5 gigahertz quad-core CPU and up to 8 gigabytes of RAM. So if you want to get a similar performance from a cloud provider, Hetzner can sell you the virtual machine with this sort of specs for like 7 or 8 euros per month. So if you do the calculation, buying your own hardware is going to pay off in about 10 months. So if you have a project that you want to run for longer than that, it might make sense. So one thing that's very important is that buying the Raspberry Pi itself isn't going to be enough. You're also going to have to figure out the storage situation. SD cards are a good solution for this. The Raspberry Pi has a built-in card reader, and it's the preferred way for you to install the operating system on. You do have to be a little bit careful when selecting your SD card because different SD cards have very different characteristics as far as performance of reading and writing data is concerned. I made this mistake. I basically, when I was configuring it for the first time, I picked a random SD card that I had lying around, and only years later I figured out that it's actually really, really slow. I only figured that out later because the databases or the data that I was storing there wasn't that much data in the first place. But now that I have a few projects that are where the database size is more than 10 gigabytes, it takes a long time to make backups and to do copy operations. So before buying an SD card, check out some benchmarks online to make sure that you buy a fast one and don't make the same mistake as I did. Now another thing that you need to be aware of when buying an SD card is that they have a limited the limited number of write and erase cycles. This means that at some point in the future it will stop writing. Now it is very difficult to figure out how long this is going to, how long an SD card is going to last for you. But the quotes are between 10,000 and 100,000 write and erase cycles, which can probably last you somewhere between 5 and 30 or more years. If you're unlucky, it's gonna, or if I'm unlucky, my SD card is going to die tomorrow, but hopefully it's going to last for a couple of more years. But this is important, so make sure that you have backups in place, just so that you don't lose any data because of this problem. Speaking of backups, USB drives are great for that. If you remember the first slide, the little stick sticking out of my Raspberry Pi, that's my backup drive. That's where I copy all of the things that I don't want to lose if something goes wrong. And they're fast, they're stable. You can even install the operating system directly on the USB drive, although I don't recommend that, just because the thing sticks out a bit more and it's much easier to accidentally hit and disconnect. I actually touched the USB drive quite often, and the green chart that we saw at the beginning would be a lot more red if the operating system was on the actual drive. So displays. You don't really need an external display to use your Raspberry Pi. You can always SSH into it if you're familiar with that. If you're not, Raspberry Pi does support up to 2 displays at once. So you can basically configure your whole development environment on it and not need SSH at all. I personally have a small 11-inch display above my other displays. I like displays, so. And it's just a way for me to see what's going on the Raspberry Pi at a given time. It shows me the CPU information, the memory, the network, and which processes are using most of the resources. Here on this graph, I can, just by glancing at it, I can see that there's some CPU usage going on, and that's because of a background task that I have running right now. So I find this super useful. And if you're not familiar, this program that I'm running is called bpytop. It's a Python version of the top program, and I mean, I just like the aesthetics of it, so I'm a big fan. Okay, so hopefully we now have the hardware sorted out. So let's talk a little about the software side, on what it takes for us to get a web server running at your home. So the recommended operating system for the Raspberry Pi is named Raspberry Pi OS. I think it was actually called or nicknamed Raspbian at some point, but this is mostly because it is based on the Debian operating system. The latest version is based on Debian 12, Bookworm, and that's, of course, a very solid base for you to start configuring your own things. Debian is also used as the distribution under Ubuntu, so it is quite popular. And because we're all Python developers here, of course I have to have a slide on how to get Python running on your machine. Here, Debian might not be the optimal choice because it does have a few quirks. So you do get Python 3.11 in the official packages, but because of Debian's package policy, you might run into an issue like this one. So Debian has the policy that only one binary can be included in one package, which is bad news for us Pythonistas because we can't live without pip, right? So to fix this, there's another package called Python full, and if you install that, it will make sure all of the dependencies are there. So pip is also going to be available on your system. Now, I personally don't like to be a few versions behind the latest and greatest Python. So what I usually do right after I configure the rest of the system is I go to python.org, download the ARM64 source code, and configure it, do the make install, make test. This sounds complicated, but it's really just a few commands that you need to run, and you have the latest and greatest Python running. Now, I know we haven't configured the web server yet, but I just wanted to give a little example on what we can do with the things that we've talked about so far. So I used to live in Slovenia, and as a surfer, I wanted to surf as much as possible, which means that I was checking the weather forecast for Croatia quite a lot to find the time to go there and surf waves. Unfortunately for me, the right conditions only happen like 5 to 10 times per year, but I was still checking the charts every day because I didn't want to miss that one time where it is actually possible to surf. And this got very depressing very quickly because most of the time the data was just not showing what I wanted it to show. Now I wish I could write a Python script that fixed this and generate the waves for me, but instead I only wrote a little script that checked the data for me, and then if something was up, if there were actually waves coming, it would send me an email like this one here. And sending emails doesn't have to be complicated. You can use a third-party service and you get a nice API or an integration with Django for it. So that's really not that difficult to get going. You just have to get a process that runs once a day and checks some APIs to get this to work. Now, as you can see, the date here is 2022. This is because I actually turned this service off a few years back, but this was only because I found a better solution for this problem, which is the fact that I moved to Portugal. And there's a lot more waves here, so no problem. Okay, but let's actually get a web server running on my machine, because that's why we're all here today, right? So I personally use Nginx to configure as my main web server. There are other options out there. Caddy is one written in Go that's very popular and might even be a little bit more user-friendly. So make sure to check that one out. But I guess I'm already old and I like boarding technology like Nginx. So that's what I use. You basically install it through the package manager, and voila, you have your web server already running. Now here, the IP address, I'm not sure if you can see it because it's kind of small, but it's the internal IP address of the Raspberry Pi in my network, which means that I can access this web server from anywhere around my house. So I have another example for how you can use just the web server without any Python yet, just because I do like simplicity and it is sometimes you don't really have to have sometimes you don't really have to have Python and Django running to achieve certain things. So as I mentioned, I moved to Portugal, but I now had a different problem. Portugal has so many beaches and they are all turned slightly differently and have different conditions. So what became the problem was figuring out where to actually go to surf, which is a good problem to have. And there are also beach camps pretty much all across the country, but they're in different, they're all on different websites, and the website of some of those websites have pretty horrible UX. So I just wanted something simple so that I can quickly check the camps that I'm interested in. So the initial version of this app, I was experimenting with Flutter at the time, so I just wanted to create a simple API. And you might think that, okay, to get JSON response from a server somewhere, you probably need Django running and REST framework or Django Ninja. But I didn't have the time to configure all of that, so I basically just I just created an API.json file and put it into the public folder in my Nginx config, and that was my JSON API. The app only needed to read the data, so it worked there. And if I wanted to add an additional camera somewhere around me, I would just SSH into my machine and edit that file there. I did later rewrite this in Django, and this is now a Django app, so that it's a little bit easier to add new things. But to get things started, you might not even need Python sometimes. So we do have our server now running on the Raspberry Pi, but now how do we put it on the internet? And this can be a little bit tricky sometimes because the way that this all works is at your home, your home has its own IP address, what we call the public IP address. So you need to connect to that. When you connect to that IP address, you're not actually connecting to a specific device on your network. Well, you actually are, but it's not the device that that's the Raspberry Pi by default. It's the router that you get from the ISP, your internet service provider. So what you need to do, you need to tell that router that all requests that are, let's say, HTTP requests are forwarded to your Raspberry Pi. And this is what port forwarding is. So if you go to your router settings, you should have a screen there that lets you manage this sort of thing. And here on this slide, I have the example for my port forwarding settings, where I basically just redirect 3 ports, 22, which is the SSH, the default SSH port, 80, which is the default HTTP port, and 443, which is the HTTPS port, to my Raspberry Pi. So that all of those connections go straight from the router to my device. Now here, I do want to point out that there is a little bit of danger when exposing your device to the internet, because the internet is a wild and dangerous place. Once you do that, you will start seeing bots trying to exploit your server immediately. And here, we Python developers we're a little bit lucky, because not all of, but I would say 90 or 95% of the bots that I've seen, they try to exploit WordPress sites. So if you're not running WordPress, you usually don't have much to fear. As you can see with these requests here on the slide, the bot was trying to access PHP files or files within the WP includes folder, which is just a 404 for my case, because I will never have those files at all. So that's one part. Nginx will make sure that things are secure on that regard. You just have to make sure to keep it up to date. But the other thing is also connecting, so the SSH port that we showed, that is also going to get a lot of hack attempts. You get random connections trying to log in with random usernames and random passwords on random ports. So you do have to make sure that the password that you chose is very secure, or better yet, that you don't use password authentication at all, and instead use public and private keys, which are a lot more secure. So yeah, keep that in mind. But if you take a little bit of precaution, it should be safe. And I think the worst thing that can happen if somebody gets in a hold of your machine is like they're going to probably just start mining Bitcoin or doing some other crazy things on your machine, and then you're going to have to reformat it, and it's going to be a downer. Okay, so when we configure the port forwarding, we now have our website running, and it can be accessed from outside of our network. But telling people to go to your IP address is kind of lame, and people kind of don't want to remember 4 random numbers. So what we need to get is a domain name, and then configure the DNS, the domain name system for that domain, which is basically to say this name, like fedidevs.com, which is going to be an example in a little bit, points to this particular IP address. For this, I personally use Cloudflare. It's a service that provides this for you for free, in addition to some DDoS protection, caching, and some other nice things. So you can, of course, set up your DNS yourself, but the DNS can be quite tricky, so using a third-party service for this is, I think, recommended. And Cloudflare is a good choice. Now, one thing that you will probably run into if you're trying to do this on your home network is that your internet service provider will change your IP address from time to time, because they usually don't give you a static IP address unless you ask really nicely, and even then sometimes they're not happy about it. So in my experience, this only happens rarely, but usually when you go out for vacation and you're not going to be at the house for like 2 weeks or something, which means that you won't even be able to access your Raspberry Pi to figure out what the new address is and fix the settings. And because this happened to me once and I was upset about it, I of course wrote a little helper tool to fix this. I called it Ipster, and it's on my GitHub page. And what it basically does, every minute or so, it does a request to figure out what your public IP address is. It does a request to figure out what the setting in Cloudflare is. And if those two numbers don't match, it updates the Cloudflare setting, so that you might lose connection for about a minute or so, but then your site is going to be back. So this brings us to my third example, which is somehow also has something to do with moving. But in this case, it was me trying to move out of Twitter and to Mastodon, because that's where all the cool people are. So I made a little website that aggregates all the accounts on all the different instances and shows and even aggregates posts for certain conferences like the PyCon Italia one. And it's Mastodon I'm a big fan of, so it's a pretty cool thing. So I'm going to now explain how I have this thing running on my Raspberry Pi still. I use, so of course, Nginx, but now we're finally going to add Django to the mix. Now to install Django, you don't have to do anything that special. Django just works on a Raspberry Pi like anywhere else. But if you want to expose it to the internet, you usually add WSGI or ASCII server in between your Python code and the web server. So GUnicorn is a good choice for that if you're old-fashioned like I am. But UVcorn is also a good option if you're trying to do async Django. So this is my config for GUnicorn that I use. The interesting thing here is the bind variable there. It basically tells GUnicorn to create a Unix socket. And this is, instead of using a special port number, we use a socket instead, a file that's basically acts as a socket. And this is just useful because we will never have port collisions if we have multiple things running, and it's an efficient way to host multiple things. I also set the procs name here, which makes it easier to see on my display what's causing the CPU usage. Now systemd is sort of, it had a bit of drama in the past, but for what I use it for, it is pretty straightforward, because you basically just create this little file, put it in your systemd folder, and this will ensure that the script that you write here in the exec start part is going to start whenever your Linux starts. And that's useful for services like the GUnicorn one, because we want to make sure that even if we throw the Raspberry Pi off the table, that when we connect it back up, that it's going to start automatically without needing us to SSH into it. And then once you have that file, you only need to enable it, and that basically makes it so that It will start when Linux starts, and then you can use the start command to start it immediately without rebooting. And now the last piece of the puzzle is telling our Nginx config to basically redirect things to our GUnicorn process that's now running on our machine. And I know this slide has a little bit of text on it. It's mostly just boilerplate. The two interesting things are the server name directive at the top that's currently bolded. This tells us which domain this particular set of settings applies to. So this particular one applies to fedidevs.com. And then the location / directive tells us what Nginx should do for this request path. And here we're basically just making sure the headers get proxied over. And the interesting part here is the last lines where we reference the sock file that we created that we mentioned in the GUnicorn config, and this is basically how we tell Nginx to use it. So HTTPS, yes, it's 2024. You rarely see a website these days that doesn't have HTTPS enabled. So how can you do it? If you want a quick duct tape solution, you can use Cloudflare's flexible SSL encryption mode. This will encrypt the traffic between the user's browser and Cloudflare, which will basically sort of trick the users thinking that everything is secure. But then the traffic between Cloudflare and your server is going to go over, is not going to be encrypted, and it's going to be out in the open. Now this, of course, isn't recommended. Like I said, it's just a quick duct tape solution. So if you want to do it properly, you install a certbot, which is the Let's Encrypt tool, and then they have an integration with Nginx. So you just run this command. It will list all of the domain names that it finds in your config, and you pick the one that you want to configure, and then it will just automatically update all of your Nginx configs and generate the certificates, and everything will just automatically start working. I was actually surprised at how easy this is. And then the only thing you have to do is make sure that this goes, that you keep updating your certificate. So you might want to do a cron job that runs this command from time to time. Okay, now that we have the website running and it's secure, we probably also want to have a way to store the data. So the easiest way to do this is just to use SQLite. SQLite is a very good database for this particular use case. For simple websites, I don't think you're going to find a better solution. And it can scale surprisingly well, maybe better than we might think. It might require some tweaking and some little changes to the configuration of it. And I have a whole other talk on this topic that I will be presenting at DjangoCon Europe. So if you want, you can also ask me about it. But since we don't have too much time, I won't go into too many details here. I will mention that for doing backups with SQLite, make sure that you use the .backup command and not just copy-paste the SQLite file manually, just because you might get a corrupt database if you do the copy commands manually. Postgres is also a good option, and you can install it easily. on your Raspberry Pi using the package manager. And again, we don't have too much time to go into the details here, but I did want to include the pgdump command to make sure that you do your backups. And finally, how do I do deployments? So we have the website running. How do I update it? I use GitHub Actions, but really this is the real duct tape of this talk. I have an GitHub action that can SSH into my Raspberry Pi, and then it just runs the following commands. It does a git pull. It installs any new requirements if I added something new. It does the manage.py commands that Django likes to do. And in the end, it restarts the gunicorn process and any worker processes that I might have. So it's, yeah, I think this is the main duct tape of the talk. And it works pretty well. I haven't had many issues with it so far. The way that I restart gunicorn is interesting. So if anyone has, if anyone's interested, I'm happy to have a brand new talk on just that topic. So in summary, what you need to do if you want to have your website running on a Raspberry Pi, you first get a Raspberry Pi and a fast SD card. You install the operating system, you get Nginx, Gunicorn, systemd to make sure the services are running. Use SQLite for storage and GitHub Actions to do the actual deployments. And that's it from my part. If you have questions, feel free to tag me on social media. All the links and some resources are on this QR code. And the website that opens up is, of course, also hosted on a Raspberry Pi. Thank you.
Okay, we have a lot of questions.
Oh.
Really. So, starting with, how do you deal with power shortage? How much power does Raspberry Pi need to run? Can power bank sustain it for some time? General question about power shortage.
Yes. So I don't deal with it at all. If my apartment is out of power, it doesn't have internet, so it is not, the sites are not going to be available in any case. So I don't do that, but if you do want to have your Raspberry Pi running, even if there's no power, Raspberry Pi really doesn't need a lot of energy, so you can just get a small battery for it, and it will sustain it for hours. But yeah, I personally haven't had the need to do that.
Do you have to deal with DDoS attacks or any other attack? Isn't it a little bit scary to expose your network? How can you mitigate these issues?
Yes, an excellent question. I don't, or at least I haven't had to deal with that because Cloudflare has protection for this. So I never expose my IP address directly. So all the internet traffic goes through Cloudflare first. And I do have, so I don't really have to deal with this at all. I do get some reports from time to time, and I see that Cloudflare does say that they prevented this and this many attacks, but that traffic usually never reaches my Raspberry Pi at all, so I don't have to care about it. But it is an important issue. Do make sure that you have something like Cloudflare running between your devices just to make sure you're safe.
How often do you back up your files? Is there any unfortunate R lesson you learned while hosting your projects?
I have automated backup jobs running pretty much every night. So if something really bad happens, I would probably lose maybe 1 day of data, which is not that big of a deal for me. And no, I don't. I guess I was lucky so far, and I've never really had to restore any backups, at least not on the Raspberry Pi. So yeah, I guess I was just lucky so far, but that doesn't mean that you shouldn't be prepared.
And do crawlers respect robots.txt?
No, they don't.
Fair. Did you try to using pyenv to have the Python version that you want compiled and installed, even more than one at once and different ones per project?
Yeah, I actually use pyenv on this laptop, but for the Raspberry Pi, I usually just use the one that's there. That does make it a little bit annoying because I have multiple projects running. I have to update all of them to make sure they work on the latest version. But the recent Python versions weren't that difficult to update, and the projects that I have running, they don't have a lot of source code. They're side projects, so not like what you're used to at your day job with 100,000 lines of code and too many issues to deal with. So it really isn't that much of a problem. But yeah, I do like pyenv. It's a cool tool.
What book, blog, report, etc. would you suggest to someone new to self-hosting?
Sorry, what kind of a
book for self-hosting in general?
I have no idea. I really don't know. There are a lot of blog posts on this topic on the internet, but I don't think I'm aware of a book on this subject. If somebody knows it, please shout it out and I'll add it. Sorry? I guess I'm going to have to write one.
What about having SSH on another port for security and avoid requests to it?
It is an option. I don't think it's. I mean, it's sort of a bit like security through obscurity. You might get less requests, but somebody might still find that port number that you're using, so they might still be able to try to exploit your server. So if you're really paranoid, that is an option, and do it. It's actually super easy to do, since you have to configure port forwarding on your router anyway, so you can just do that on that level. The reason why I don't do it is because I'm lazy and I just don't like the fact that you need to then specify the port number in your SSH config. But like I said, if you're paranoid about security, that's also one step that you can take. Do know that it's much more important to use a good password or an SSH key to protect yourself. This alone won't help that much.
How do you send emails? Do you use a cloud SMTP service or do you send emails directly from the Pi? Do they always deliver?
Yes, I use a cloud SMTP server. I have run my own SMTP servers for a long time, and I don't recommend it. It's just too much of a hassle because of spam filters and all of that. So yeah, I think here it's just best to use a cloud provider for it. It is always a little bit tricky, even if you're sending like 1 email per day or 5 emails per year, like for my Wave Watcher project, I did still get the issue that it sometimes went into spam. So there's a lot of little things that you have to tweak to make sure the emails are delivered well. And that's probably a whole nother talk in itself.
Do you think we can set up a VPN server on Raspberry Pi with a setup similar to yours?
Yeah, I think you can do that. I think there's even very popular Raspberry Pi projects. I think Pi-hole might be one. I haven't done that myself. Yeah, Pi-hole. So you basically just install that software and you have a little VPN running that you can use. It's super, super cool, I'm told.
Last question. Would Docker enhance the security?
I don't. Well, that's a good question. it won't make it impenetrable, but it might help prevent contamination from one process to another. So there is a little bit of security benefit from it, but I wouldn't base my security policy just on using Docker. There are also, as far as I'm aware, there are also exploits that can escape the Docker environment and still do nasty things around your computer. But I'm not that up to date on this because I prefer to not use Docker in this on my Raspberry Pi just because of the resource constraints and the simplicity of it all. It's just like another tool and another set of things that you need to be managing, and I like to keep my life as simple as possible.
All right, thank you very much.
Thank you.